What's in a name? When we talk about data science, are we just using a trendy buzzword for an old practice? Or does the name itself hold a deeper meaning, a clue to a fundamental shift in how we understand the world? The story of this term is a journey not unlike our travels through space-time. It reveals how humanity once gazed at the stars to find patterns and now looks into vast oceans of digital information to discover the hidden laws of our own universe. This isn't just a story about a job title, it's about the birth of a new way of seeing, a new instrument for inquiry as powerful as any telescope. The label we give a field shapes our expectations, it frames the questions we ask. It shapes the tools we build. Calling it data science was a deliberate choice. It wasn't just statistics 2.0 or advanced business analytics. The word science carries weight. It promises rigor and systematic methods guided by evidence and experimentation. It suggests a discipline as fundamental as physics as it does biology. But its subject is the very fabric of information. Our story begins long before the first silicon chip. Its roots lie in the fertile ground of statistics, a discipline dedicated to making sense of uncertainty. Pierre-Simon Laplace, orbits of planets, outcomes of games of chance. They were the original data detectives using mathematics to find signals in the noise of the world. Then came the revolution. The 20th century witnessed the birth of the computer. Early pioneers like Alan Turing. He didn't just invent a machine, he unlocked a new realm of possibility. Suddenly the laborious calculations that took statisticians weeks could be done in seconds. This wasn't just an acceleration of the old ways, it was a transformation. The computer allowed us to work with datasets of a size and complexity that were previously unthinkable, moving from neat tables to messy, sprawling archives of information. The marriage of statistics and computation was the spark. John Tukey, a giant in the world of statistics, he championed a new philosophy he called exploratory data analysis. He urged his colleagues to be more like detectives, to use graphical methods to let data reveal its secrets. He was advocating for a more interactive, curious, and computer-assisted approach to statistics. This was a critical step away from traditional methods. Thinkers like Peter Nauer were already using the word datalogy in the 1960s. He saw that handling data was becoming a discipline distinct from the machines that processed it. The idea of a science dedicated to data didn't appear overnight. It emerged in whispers and lectures and academic papers. Different thinkers arrived at the same conclusion. One of the earliest, most forceful voices, Jeff Wu, 1997, lecture at the University of Michigan, a bold proposal. Rename statistics to data science, rename statisticians to data scientists. The old name missed the work's full scope. It now included data collection preparation at massive scale, not just analysis. Professor Wu's call was prescient. Data was expanding beyond clean, structured datasets. The work was getting messier, more hands-on, wrestling with raw information, cleaning it, shaping it, preparing it for analysis, an art as much as a science. Traditional statisticians equal sign chefs with prepackaged ingredients. New data scientists equal sign chefs at the market picking raw produce, preparing from scratch. A broader skill set was required. Not just math and stats, comfortable with computing, comfortable with databases, domain knowledge biology, domain knowledge astronomy, domain knowledge business. Wu outlined an interdisciplinary field at the crossroads of established disciplines. A jack of all trades who follows a question from raw data to meaningful insight. If Jeff Wu proposed the name, then William S. Cleveland wrote the first true charter for data science. In 2001, he published a groundbreaking paper titled Data Science, an action plan for expanding the technical areas of the field of statistics. This wasn't just a suggestion, it was a detailed manifesto. Cleveland, a highly respected statistician at Bell Labs, laid out a concrete plan for creating this new discipline. He argued that data science should be recognized as a distinct field and taught as such in universities. Cleveland's vision was remarkably complete. He broke down the work of a data scientist into specific areas of focus, multidisciplinary investigations, emphasizing collaboration with subject matter experts, models and methods for data, covering traditional statistics, computing with data, pedagogy, tool evaluation, theory. He saw data science as a holistic discipline, encompassing the entire lifecycle of data, from collection and computation to theoretical underpinnings and teaching the next generation. This paper was a watershed moment. It gave formal structure and academic legitimacy to long-percolating ideas. Cleveland proposed expanding and renaming university statistics departments, allocating around 50% to the practice of data science. He argued the field needed to focus on practical, real-world problems, and build tools for massive, complex datasets. It was a bold, forward-looking plan. It addressed the changing landscape of information. The transition of data science from an academic concept to a business buzzword happened with astonishing speed. The catalyst was the explosion of consumer internet companies in the mid-2000s. Companies like Google, Amazon, a newcomer called Facebook were built on data. Their very existence depended on their ability to understand user behavior at an unprecedented scale. They needed people who could do more than just traditional business analysis. They needed people who could build systems that learned from data. They needed the people Cleveland and Wu had described. In 2008, DJ Patil at LinkedIn and Jeff Hammerbacher at Facebook independently formed the first formal data science teams. They chose the title deliberately. They were looking for a rare breed who combined statistical rigor with software engineering skills. These were people who could not only analyze vast data sets but also build products and algorithms that would use those analyses in real time, like recommendation engines, friend suggestion algorithms. The term data scientist became a beacon to attract this unique talent. The popularization reached a new peak in 2012 when Harvard Business Review published an article titled, "Data Scientist: The Sexiest Job of the 21st Century." This article, co-authored by DJ Patil himself, catapulted the term into the global consciousness. Suddenly, every company, retail giants, financial institutions wanted a data science team. Universities rushed to create master's programs in data science to meet the soaring demand. The academic discipline envisioned by Cleveland had become a full-blown industrial revolution, reshaping economies and creating a new nexus of power and knowledge. Today, on September 21, 2025, the story of this name serves as a powerful reminder. It tells us that the most transformative ideas often emerge at the intersection of different fields. The future of technology is not just about faster computers or bigger datasets. It's about our ability to ask meaningful questions and to develop a science for answering them. The journey of data science from a statistical lecture to a global phenomenon shows us that naming something is an act of creation. It defines a new way of seeing, and in doing so, it helps us build the future we are trying to understand.